Mount Vesuvius, one of the most notorious volcanoes, has long been dormant, but recent activity in the Campi Flegrei region has ignited concerns about a possible eruption. Situated near Naples, Italy, Campi Flegrei, or the Phlegrean Fields, is a supervolcano that has shown increased seismic activity, prompting scientists and residents alike to question if Vesuvius might be next. The significance of Vesuvius lies not only in its historical eruptions, but also in the potential threat it poses to the densely populated areas surrounding it. With approximately 400,000 people residing in the vicinity, the stakes are high. Understanding these patterns is essential for assessing the risks and preparing for potential scenarios that could unfold. The story of Vesuvius and Campi Flegrei is one of both awe and caution, reminding us of the volatile nature of the earth beneath our feet. By examining the latest studies and expert opinions, we can better grasp the implications for the future and the measures necessary to protect those at risk. Campi Flegrei's history is marked by a series of powerful eruptions that have left indelible marks on the landscape. Approximately 40,000 years ago, a colossal eruption formed a 9-mile-wide caldera, significantly altering the region's topography. The Maddaloni X6 eruption, dating back 109,000 years, was one of the largest explosive events recorded, contributing to the complex geological structure of the area. These past eruptions serve as critical reference points for scientists studying volcanic activity, providing valuable insights into the potential for future eruptions. The last recorded eruption occurred in 1538 and was notably different in scale and impact. Despite being a much smaller event, this eruption demonstrated the dynamic nature of the region, with rapid ground uplifting observed then, mirroring current developments. Understanding the historical context of Campi Flegrei is essential for anticipating future volcanic activity. By analyzing past events, scientists can build predictive models and enhance their understanding of the underlying mechanisms driving these eruptions. This historical perspective is invaluable for informing current research and preparedness strategies. The recent uptick in seismic activity within the Campi Flegrei region has sparked alarm among scientists and residents. With a population of approximately 400,000 living in proximity to the caldera, the potential risks of an eruption are significant. The concern is not merely theoretical, it is grounded in observable changes within the volcanic system, including ground uplift and increased seismicity. Beyond the immediate dangers of volcanic blasts, there are longer-term implications for air quality, infrastructure, and livelihoods. Scientific observations indicate that the current unrest may be due to fluid buildup rather than direct magma movement. This distinction is crucial as it influences the nature and potential severity of an eruption. However, the current situation underscores the importance of continuous monitoring and the need for effective communication of risks to the public. Preparedness efforts must be informed by the latest scientific insights to ensure the safety of those living in the shadow of Campi Flegrei. Recent studies have provided a deeper understanding of the Campi Flegrei's current state and potential future activity. A notable study published in May 2025 in Nature Communications suggests that the ongoing unrest is likely due to fluid accumulation within the caldera. This finding is significant as it shifts the focus from magma movements to the role of hydrothermal processes in driving seismic events. Another key study, led by Giada Fernandez and published in January 2025, explored the historical context of the Maddaloni X6 eruption. Using advanced modeling techniques, the research team highlighted the eruption's scale and impact, providing a benchmark for evaluating contemporary volcanic activity. By focusing on fluid dynamics, researchers can develop more accurate predictive models, enhancing the ability to forecast potential eruptions. Moreover, these scientific advancements have practical implications for risk management and public safety. By distinguishing between fluid-driven and magma-driven activity, authorities can tailor their response strategies accordingly. Section 5. Techniques in volcanic research. The study of volcanic activity, particularly in complex systems like Campi Flegrei, relies on a range of cutting-edge research techniques. High-resolution seismic imaging is a primary tool used by geologists to delve into the subsurface structures of the caldera. This technique allows researchers to create detailed models of the underground environment, revealing key features that influence volcanic behavior. Rock physics experiments conducted on deep well samples provide additional insights into the physical properties of the volcanic system. These experiments simulate the conditions within the caldera, helping scientists understand how the rock formations respond to stress and fluid pressure. Researchers also employ borehole drilling to gather direct samples from beneath the surface. By combining data from multiple sources, scientists can develop a comprehensive understanding of the caldera's dynamics. This multidisciplinary approach is essential for addressing the complex challenges posed by volcanic systems. Section 6. Key structures in the volcanic region. The Campi Flegrei caldera is characterized by a series of complex geological structures that play a crucial role in its volcanic activity. At the surface lies a fibrous caprock layer consisting of volcanic products deposited over thousands of years. This layer acts as a protective barrier, modulating the movement of fluids and gases within the caldera. Beneath the caprock, a gas-enriched reservoir functions like the lungs of the volcanic system. This chamber, filled with water and steam, experiences pressure build up over time, contributing to the observed seismic activity. Further down lies a stable basement, a dense carbonate-rich formation that provides structural support to the caldera. The identification of these key structures has been instrumental in advancing our understanding of Campi Flegrei. This knowledge is essential for predicting potential eruption scenarios and implementing effective monitoring and preparedness measures. Section 7. Monitoring and preparedness efforts. Monitoring volcanic activity in the Campi Flegrei region is a critical component of risk management. Continuous surveillance allows for the early detection of changes in the caldera's dynamics, providing valuable time to implement emergency response plans. Recent advancements in monitoring technology have enhanced the ability to track seismic activity, ground deformation, and gas emissions. These data points provide a comprehensive view of the caldera's behavior, enabling scientists to identify patterns and trends that may indicate an impending eruption. Preparedness efforts extend beyond scientific monitoring to include community engagement and education. Local authorities have developed evacuation plans and conducted drills to ensure residents are familiar with emergency procedures. The importance of monitoring and preparedness cannot be overstated. By integrating cutting-edge research with practical measures, authorities can enhance resilience and ensure the safety of those living in the shadow of this formidable geological feature. Section 8. Expert opinions on volcanic activity. Expert opinions provide valuable insights into the complexities of volcanic activity and the risks associated with Campi Flegrei. Christopher Kilburn, a renowned volcanologist at University College London, emphasizes the need to consider the entire Campanian plain as a potential eruption zone. Kilburn asserts that while a major eruption is unlikely on human timescales, understanding the region's volcanic history over tens of thousands of years is crucial. This long-term perspective provides context for current activity and helps refine predictive models. By examining the geological record, scientists can better anticipate potential scenarios and develop strategies to mitigate their impact. Other experts echo the importance of ongoing research and monitoring to enhance understanding of Campi Flegrei. The insights provided by experts are instrumental in shaping public policy and informing community preparedness efforts. This collaboration between researchers, policymakers, and the public is essential for ensuring the safety and resilience of communities living in proximity to active volcanic systems. Section 9. Conclusion: Implications for the future. The findings from recent studies on Campi Flegrei underscore the importance of continuous monitoring and research to assess the risks posed by this volcanic region. While an eruption is not considered imminent, the potential for significant activity remains, necessitating ongoing vigilance and preparedness efforts. The integration of advanced research techniques and expert insights has enhanced our understanding of the complex dynamics driving volcanic activity. By distinguishing between fluid-driven and magma-driven activity, authorities can tailor their response plans to address specific threats. This nuanced understanding is crucial for ensuring the safety of the local population and mitigating the impact of potential eruptions. By fostering a culture of awareness and preparedness, communities can better navigate the challenges posed by living near an active volcanic system. By leveraging the latest scientific insights and engaging with expert opinions, we can enhance our resilience to volcanic threats and ensure the safety of those living in the shadow of this formidable geological feature.